Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've seen two major sources of endogeneity, omitted variable bias and reverse causality. In these two cases, the problem was identical and it was because the covariance between your x variable and the error term was actually different from zero. So the question is, how do we get around it? We came up with two different ways to deal with it in the case of the omitted variable bias. In this particular case, of simultaneity or reverse causality, we need a source of variation in X that is completely untouched by the contamination. That's why the solution for this is finding an instrument. So we need an instrument that provides a clean source of variation in X that's completely untouched by contamination. If you remember that feedback arrow that we saw in the previous video. So what do we have to do in order to get that instrument? Suppose that we want to estimate a model that is y equals to beta 0 plus beta 1 x plus the error term. Ideally, we would want to run an experiment, randomly assign different levels of x to different people, then measure the y, okay? So random assignment normally would break the link between the x and the error term. Ability, motivation, family background, they would all be uncorrelated with x by design, okay? So in experiment cases, we have a random assignment. However, with observational data, the story is a little bit different, right? Because ability moves with education. Income affects education. Motivation affects both. So we never observe pure changes in X. Everything moves together. And this is also one of the reasons why randomized experiments are so powerful and why the IV is the best observational alternative, okay? IV instrumental variable tries to mimic what an experiment would have done in that sense, okay? So let's introduce now this new variable Z that we called the instrumental variable, okay? We have a sequence that goes like this. Z is affecting X and then X affects Y. An instrument is a variable basically that moves X, but is not itself part of the endogeneity problem because the Z is not part of the error term, okay? Which means that instead of using all the variation in X, which was like contaminated, we use only the variation in X that was created by Z. So use variation in X created by Z. Z, think of it as like this remote control for X. What do I mean by that? It moves X, but only through a clean channel, one that basically bypasses the contamination. Think of X as having two components, and keep in mind, you've seen this idea when we talked in the video about the Frisch-Wallow theorem. So we're doing exactly the same thing in here. We've got X being composed of clean variation plus the contaminated variation. The contaminated variation, this is where you got all of the other things that are mixed up. So you've got ability here, you've got motivation, you've got reverse causality as well. Okay. The clean variation, these are the things of X that move independently. So this clean variation, in the case when we use Z as an instrument, will be the part of X driven or controlled by Z. And Euler uses all the variation in X, clean and contaminated together. IV as a methodology uses only the clean variation part, all right? And again, this is indirect connection to the Frisch-Wahlowel theorem that you have seen before, okay? Because you are identifying the beta hat from independent variation in X. All right, so IV finds that independent variation through Z, even when X itself is endogenous, okay? So imagine, for instance, that you've got X as years of education in uni, okay? The endogeneity problems that you would have are all of this in here: ability, motivation, and the reverse causality that is coming from Y. So it's clear that the covariance between X and the error term is not zero. When you introduce this new Z variable, the one that we will use in this particular case is distance to nearest university. Okay. What we're doing is people who grew up closer to university tend to get more education. So it's not just because of ability, but simply because it's more accessible and cheaper to attend. Okay, so in this case, we're proving the channel, the first part of that sequence, Z to X. Okay, now distance to a university doesn't determine your earnings. So this relation in here does not exist. Okay, and distance to university doesn't have anything to do with your abilities, with your motivation. So even this direction in here does not exist in this particular case, okay? So we found this instrument, distance to nearest university, which only affects Y through X, because there's no other like arrows that connect Z directly to Y. By the way, if you're wondering, this comes from a very famous paper for Card 1995 on the instruments, one of the most famous in labor economics, and he was the first to use like distance to college to estimate basically the return to education, precisely because distance created this clean variation in schooling that is plausibly unrelated to ability. Why does this help? Instead of comparing with different education levels, which means that you would be mixing ability, motivation, family background, we compare people whose education differs because of how far they lived from a university, okay? So that difference is much closer to random. Two people of similar ability who happen to grow up at different distances. The one closer to a university is the one that gets more schooling. And we use that difference to estimate basically the beta 1 hat. And this is the main key intuition. You're not using all the variation in education. You're only using the specific slice of it that is potentially clean, okay? Another example that you will see quite a lot is the lottery analogy. So imagine education was assigned by lottery. Differences in education, in that case, would be purely random, uncorrelated with ability, motivation, or anything else. So an instrument tries to literally mimic that idea. So IV tries to mimic a lottery. That's why you will see a lot of examples and a lot of exercises that involve some sort of a lottery when you're dealing with IV exercises. So whenever we use an instrument that tries to mimic that idea, it's not going to be a perfect experiment, but at least it creates variation that is potentially exogenous, variation that looks for our purposes as if it were randomly assigned, okay? This is also the reason why IV estimates are sometimes called local, because they capture the causal effect for the people whose behavior was actually changed by the instrument. But we'll come back to this idea later. There are certain conditions what makes a good instrument, but we'll dive in a little bit deeper into each of these conditions in our separate videos. What I'd like you to remember as a big conceptual takeaway is that the instrument gives us a source of variation in X that is unrelated to the endogeneity problem. And instrumental variables basically work by isolating that claimed variation in X through Z, only using that variation to estimate beta 1. In the next video, we'll study the first condition, which is relevance. So stay tuned, and I'll see you in the next video.